You think light speed is just a number. 299,792,458 meters per second fast. Incredibly fast. The fastest thing in existence, okay? But why is it the ultimate limit? Why can T anything exceed it? What is actually stopping you? Most people never truly question this. They simply accept it. Einstein declared it. Light speed is the universe. S speed limit, that is just reality. But that is not really an answer. That is just echoing words. When you genuinely ask why nothing can surpass light speed, when you probe what is truly preventing you, you uncover something so bizarre, so fundamentally alien to everyday experience, that it transforms everything you believe about space and time. Light speed isn't merely a velocity. It is not simply the fastest phenomenon. It is the architecture of reality itself. It is embedded into the fabric of space-time in a manner that makes exceeding it literally impossible. Let me demonstrate what I mean. Let S begin with something straightforward, something universally known. Objects fall. Release something. It drops downward. 16 feet in the first second, to be exact. That is what Galileo determined. Release a ball, release a stone, release anything. Within 1 second, it descends 16 feet. Now consider the moon. The moon orbits the Earth. It is not plummeting downward. It remains up there circling, traveling in a loop. But hold on, is it actually falling? Consider this carefully. If the moon were simply stationary in space, motionless, what would occur? It would plummet toward Earth. Gravity would drag it inward. But the moon is in motion. It is traveling sideways, tangential to its orbital path. And because it is moving laterally, while gravity tugs it downward, it continuously misses Earth. It falls toward Earth, yet keeps missing. That is the nature of an orbit perpetual falling, while moving sideways rapidly enough to keep missing. Here is where Newton achieved his genius breakthrough. The moon sits 240,000 miles from Earth's center. We stand on the surface rapidly enough to keep missing. Here, 4,000 miles from the center. The moon is therefore 60 times more distant than we are. Newton proposed, what if gravity weakens with distance? What if it obeys an inverse square relationship? Meaning if you double the distance, gravity becomes 4 times weaker. Triple the distance, 9 times weaker, the square of the distance. If this holds true, then at the moon's location, 60 times farther, gravity should be 60 squared times weaker. That is 3,600 times weaker. On Earth, objects fall 16 feet in 1 second. If gravity at the moon is 3,600 times weaker, then the moon should fall toward Earth by 16 feet divided by 3,600. Calculate it 16 feet divided by 3,600. That is approximately 1/20th of an inch per second squared. Actually, let me rephrase that. In 1 second, something at the moon's distance should fall toward Earth by 1/20th of an inch. Newton calculated how far the moon should fall toward Earth in 1 second if gravity follows an inverse square law, and it matched flawlessly. The moon is falling at precisely the rate Newton's law predicts. This was monumental. This wasn't merely theory. This was prediction. Newton took a completely independent observation, how rapidly things fall on Earth, and linked it to another completely independent observation, the period of the moon's orbit and its distance from Earth. 2 phenomena that appeared totally unrelated suddenly became unified by one law, the law of gravitation. There was no turning back. Newton pushed further. He calculated what planetary orbit shapes should be if gravity follows an inverse square law, and he discovered they should be ellipses. And what do you know? Planets do travel in ellipses. Kepler had already measured this, but Kepler didn't understand why. Newton explained it. He achieved 3 confirmations from 2 principles, as it were, and then additional pieces aligned. The tides. Why do tides exist? Because the moon exerts pull on Earth. But wait, if the moon simply pulls Earth uniformly, there should only be 1 high tide daily, correct? The water bulge on the side facing the moon. But there are 2 tides daily, roughly every 12 hours. Why? Some believed Earth was pulled away from the water. Others believed the water was pulled toward the moon. Both were partially correct, but neither grasped it fully. Roughly every 12 hours, Newton understood what was truly happening. The moon's force on Earth and on water is identical at equal distances. But the water on the near side is closer to the moon than Earth is, so it experiences stronger pull, and the water on the far side is more distant from the moon than Earth is, so it experiences weaker pull. Thus you get two bulges, one where water is pulled more toward the moon than Earth is, so it experiences stronger pull. Thus you get two bulges, one where water is left behind because Earth is pulled more than that water. Two tides daily, actually. Earth performs the same motion as the moon. It revolves around a circle. The circle's center lies somewhere within Earth. Earth and moon both orbit their shared center of mass. If you prefer, this water is flung outward by centrifugal force more than Earth is, and this water is attracted more than Earth's average. Regardless, the tides were explained, including why they occur twice daily. Many other phenomena became clear. Why is Earth round? Because everything gets pulled inward. Why is it perfectly round? Because it is rotating, so the exterior gets thrown outward slightly, achieving balance. Why are the sun and moon round, and so forth? As science advanced and measurements became increasingly precise, tests of Newton's law grew much more rigorous. The initial careful tests involved Jupiter's moons through meticulous observations of their orbital patterns over extended periods. One could verify thoroughly whether everything aligned with Newton's laws, and it turned out not to align. Jupiter's moons appeared to arrive sometimes 8 minutes ahead of schedule, and sometimes 8 minutes behind schedule, where schedule means the calculated values according to Newton's laws. 8 minutes, that is a massive discrepancy. Something was incorrect. But wait, it was observed that they were ahead when Jupiter was near Earth, and behind when Jupiter was distant. Rather peculiar circumstance. Mr. R. Famer, maintaining confidence in the law of gravitation, reached an intriguing conclusion. Light requires time to travel from the moons to Earth, and what we observe when we see the moons is not their current state, but their past state. The time it took light to arrive here. When Jupiter is nearer, light takes less time to arrive. When Jupiter is farther, it takes longer, so he had to adjust the observations for time differences. And from the fact that they were this much early or that much late, he determined the velocity of light. This was the first demonstration that light doesn't propagate instantaneously. Consider what just occurred. We discovered light's speed, not by measuring light directly, but by trusting the law of gravitation. When something didn't align, instead of discarding Newton's law, R. Famer proposed, what if light requires travel time? And he was correct. I highlight this particular matter because it illustrates something. When a law is valid, it can be used to discover another. By trusting this law, if something is wrong, it suggests perhaps some other phenomenon. And if we hadn't known the law of gravitation, we would have taken much longer to find light's speed, because we wouldn't have known what to expect from Jupiter's satellites. This process has evolved into an avalanche of discoveries. Each new discovery provides tools for much more discovery. And this beginning, it is the start of that avalanche, which has continued now for 400 years in a continuous process. And we're still avalanching along at high speed currently. But here is the thing. Once you know light's speed, once you measure it, you start noticing something very, very peculiar. Light always travels at identical speed, always, regardless of who measures it, regardless of how fast you are moving. Let me make this concrete. You are stationary. You shine a flashlight. You measure the light's speed coming out, 299,792,458 meters per second. Fine. Now you board a train, a rapid train, moving at, say, half light speed. You shine the flashlight forward in the train's direction of motion, of motion. Common sense suggests the light should now travel at light speed plus train speed. Just like if you throw a ball forward from a moving train, the ball moves faster than if you threw it while stationary. But that is not what occurs. You measure the light, It is still traveling at 299792458 meters per second, exactly identical speed, you think. Okay, maybe I measured incorrectly, so you accelerate the train even faster, 90% light speed. You shine the flashlight forward again. You measure still 299792458 meters per second. You become frustrated. You accelerate the train to 99.9999% light speed. You shine the flashlight. You measure still the same speed. Light speed does not add. It doesn't combine with your velocity. It is always identical regardless of how fast you are moving. This should shatter your understanding. This is not how velocities work in everyday life. Velocities add if you are on a train moving at 50 miles per h-hour and you walk forward at 3 miles per h-hour. You are moving at 53 miles per h-hour relative to the ground, but light doesn't behave this way. Light always moves at identical speed relative to you, regardless of how fast you are moving. Why Einstein realized what was happening, and it is so strange, so contrary to intuition, that even now, over a century later, people struggle to accept it. Time and space are not fixed. They're reflexible. They bend and stretch to maintain light speed constant. When you move faster, time decelerates for you. Your clock literally ticks slower and distances contract. The space ahead of you gets compressed. These effects are real. They are not optical illusions. They are not measurement errors. Time actually decelerates. Space actually contracts, and the amount they change is precisely the right amount to make light speed identical for everyone. Let me repeat that. The universe adjusts time and space, bends them, stretches them, compresses them to ensure that light always travels at identical speed for everyone. Light speed is not merely a velocity. It is a structural constant of the universe. Space and time are arranged such that this speed is identical for everyone. Now here is where it becomes even stranger. If you attempt to accelerate something, anything to light speed, something very peculiar happens. The closer you approach light speed, the harder it becomes to go faster. It is not that you exhaust fuel. It is not that your engine isn't powerful enough. It is that the object itself resists acceleration increasingly. We call this relativistic mass increase. As you go faster, your inertia increases. It becomes progressively harder to push you faster. And as you approach light speed, your inertia approaches infinity. To actually reach light speed, you would require infinite energy, which is impossible. So nothing with mass can ever reach light speed, not because of some arbitrary rule, not because of engineering limitations, but because space-time's structure itself prevents it. Light can travel at that speed because photons have no mass. Zero massless particles can travel at light speed. In fact, they have no choice. They are always moving at that speed, but anything with mass, it can get close. Very close. 99.999% of light speed, but never quite there. The universe permit you. Now you might ask, but why? Why is the universe configured this way? Why is there a speed limit at all? And here is the answer that is going to frustrate you. There is a deeper why. Light speed isn't a speed limit imposed on the universe. It is a consequence of how the universe is structured. Space and time are not separate. They are woven together into space-time. And space-time has a geometry, a structure, and that structure has a built-in conversion factor between space and time. That conversion factor is light speed. It is not that light is special. It is that space-time has a maximum rate at which cause and effect can propagate. Light happens to travel at that rate because light has no mass. But the rate itself is a property of space-time, not of light. If light didn't exist, the speed limit would still exist. It is a feature of the universe itself. Here is another way to think about it. In everyday life, you think of space and time as separate things. You move through space. Time passes. They independent, but they not. You are always moving through space-time at a constant rate. Always. But that motion is divided between space and time. If you are sitting still, all your motion is through time. You are moving into the future at maximum speed, 1 second per second. But if you start moving through space, you must divert some of that motion away from time. You are now moving through space and time, which means you are moving through time more slowly. The faster you move through space, the slower you move through time. And there is a maximum. If you could move through space at light speed, you would have zero motion remaining for time. Time would stop for you. This is why light doesn't experience time. From a photon's perspective, it is emitted and absorbed in the same instant. No time passes. The universe is frozen. You can exceed light speed because you can have less than zero motion through time. That is the limit. That is the barrier. And here is the beautiful part. This isn't merely theoretical. We've tested this repeatedly. Particles in accelerators get accelerated to 99.99999% of light speed. And what happens? The closer they get, the harder it becomes to accelerate them further, exactly as predicted. GPS satellites must account for time dilation. They re-moving rapidly, and they in a weaker gravitational field. So time passes differently for them than for us on the ground. If we didn't correct for this, GPS would be off by miles within a day. Muons created in the upper atmosphere by cosmic rays should decay before reaching the ground. Their lifetime is too brief, but they're moving close to light speed. So time slows down for them. From their perspective, they live long enough to reach the ground. From our perspective, they live longer because they're moving fast. Either way, more muons reach the ground than should, exactly as relativity predicts. It is not speculation, it is measured. Light speed being a limit is as well tested as anything in physics. So let us bring this all together. Why is light speed the limit? Because space-time is structured in a way that has a maximum rate of cause and effect. That rate is light speed, not because light is special, but because space-time itself has this built. In conversion factor between space and time, you can go faster, because going faster would require moving backwards in time, which doesn't make sense. You can have negative time, you can undo cause and effect. Light speed is the speed at which now propagates through the universe. It is the speed at which information can travel. It is the speed at which forces act. It is the maximum rate of change. And this process, this avalanche of discoveries, started with Newton determining gravity by observing the moon. Then, our Famer determining light's speed by observing Jupiter's moons. Then Einstein realizing that light speed is constant and deriving relativity from that. Then thousands of experiments confirming it. Each discovery building on the previous, each new insight opening doors to more insights. That is how science operates. That is the avalanche that has been ongoing for 400 years, and we're still avalanching along at high speed. Currently, light speed isn't just a number. It is the key. It is the thing that unlocks how space and time function. It is the thing that reveals the universe is stranger and more beautiful than we ever imagined. And the fact that we can understand it, that we can measure it, test it, use it to make predictions. That is the beauty of physics. Not comfort, not simplicity. Truth